Since we have recorded the first playlist, some new protocols developed for use in Internet of Things systems have appeared. One of them is Thread. Thread operates on the same 802.15.4 radio as Zigbee or Z-Wave, but instead of using its own addressing scheme, uses IPv6 addressing. It can form a mesh network with devices playing different roles, routers or end devices. A router is a node that forwards packets for other network devices and provides secure commissioning of devices joining the network. Router keeps its transceiver enabled at all times to be able to communicate instantly if required. An end device is a node that communicates primarily with a router. It is worth mentioning that the end device communicates with only one router, which plays the role of its parent node. It doesn't forward packets for other devices in the network. End device can disable its transceiver to reduce power consumption. There is always one thread leader in the network which operates as the main router and manages other routers. To connect the thread network to external non-thread networks, the border routers are used. Any device can be the border router, and there can be multiple border routers in one network. There is also another division depending on the behavior of the devices. Full thread device, which keeps the radio always on. It can be a router, end node, which can change the role to a router, called router eligible end device, or full end device, which can't play a router role. Minimal thread device, which can be minimal end device, which radio is always on, or sleepy end device, which is normally switched off and can periodically pull for new data. Thread was developed as the modern secure IoT protocol compatible with IPv6. It incorporates encryption, authentication, and secure key management to protect communication between devices on the network. It is also energy efficient, allowing devices to fall asleep and awake when needed for communication. To achieve this, implemented mechanisms cover asynchronous communication, scheduled sleep, adaptive data rates, wake on radio, and waking up only a selected group of devices called paging. Routing protocol concerns the device's energy resources. Modern addressing scheme ensures a sufficient number of addresses available. Another protocol which implements IPv6 addressing in IoT networks is 6LoWPAN. The name of it is abbreviation of IPv6 over low-power wireless personal area networks. This protocol is based on edge routers which allow connecting 6LoWPAN networks with other networks. As a result, every node can be visible on the Internet and uniquely addressable. 6LoWPAN creates the adaptation layer that has been developed to operate on the radio channel defined in 802.15.4, for example with Zigbee, Z-Wave, and Bluetooth Smart. 6LoWPAN supports two addressing models, 64-bit and 16-bit. The former limits the number of devices connected to one network to 64,000 nodes. Notice that full IPv6 has 128-bit addressing scheme. The primary frame size is smaller than in full IPv6, being just 127 bytes compared to more than 1000 bytes. 6LoWPAN supports unicast and broadcast. It also supports IP routing and mesh networks which can have more than one edge router. 6LoWPAN uses auto-configuration for neighbor device discovery, so it doesn't require a DHCP server. It also supports safe, ciphered transportation using AES-128 and AES-64 for constrained devices. 6LoWPAN devices can be just nodes, called hosts, or nodes with routing capability as shown in the picture. The edge router implements a gateway between 6LoWPAN and the regular IPv6 network, or IPv4 for compatibility with still popular network protocol. It aims to translate compressed 16 or 64-bit addresses to full IPv6, ensuring bidirectional communication between the Internet and 6LoWPAN nodes. Although the physical connections between devices make the network operate like classical mesh, the logical network structure is flat, with single addressing space, and devices have unique MAC addresses to be recognizable by the edge router device.